Hi everyone, my name is Gabriel and I'm your SAT math tutor from SAT Prep course. And today we're going to see a little bit about percents, simple and compound interest, a really important matter that always is in the SAT math test. So first, let's move on percents. Well, we have the definition of percents. That's basically when you have a part of something. If you say you have X%, you have simply X divided per 100. For example, if you have 15%, you have 50 divided by 100. Great, so an example, what is the value of 20% of 40? It's super easy. You have 20% multiplying 40. And that's equal. It's just cut zeros here and you have 8. Well, it's basically you have 0.2 multiplying 40 and that's equal 8. So moving on, we have increasing in percents. For example, let's assume that the iPhone's price increased in the last year in 10%. If its initial price was $700, how much does it cost today? So we had $700 and an increase of 10%. So I'm adding 10% of its initial price. Now it's going to cost the initial price plus 10% of its initial price. And this is going to give us 700 plus $70. $770. Great, and this is the final price. So generalizing, if we have an increase of X% in a price of Y, this means that we have this price Y plus X% of Y. And this is equal to Y plus 0.01x multiplying Y. I'm sorry guys, this is a dot, not a comma. Multiplying Y. Great, if we separate Y in evidence, this is multiplying 1 plus 0. Again 0.1x. Great, so if we have an increase of 10%, we're gonna have Y multiplying 1 plus 0.01 multiplying 10. That is the increase, 10%. So we finally are going to have 1.1y. If we have an increase in 20% of y, we're going to have 1.2y. And finally, if we have an increase of 100% in y, we are going to have 2y. And this is super easy because let's assume that you have $5. What is 100% of $5? It's $5 again. So if I have an increase of 100% in $5, I'm gonna have $10. And this is just 2 multiplying $5. Okay guys, so let's move on to decreasing in percents. For example, if we have a decrease of 10% in $700, we're gonna have the same amount, $700, minus 10% of 700. This is going to give $700 minus 70. That is 10% multiplying 700 equals to $630. Okay, so now we can generalize the same way we did with increasing. If we have a decrease of X% in Y, this is basically the number Y minus X% of Y. Developing this, we have Y multiplying 1 minus 0.01x. Notice that 1 divided by 100 equals to 0.01, and I'm multiplying by x. So if we have a decrease of 10% in y, we have y multiplying 1 minus 0.1, that is 0.9y. Likewise, a decrease of 20% equals to 0.8y. And finally, a decrease of 100% equals 0y. This is quite obvious because 100% is the same number. If we decrease x in x, we're gonna have 0. So let's have an example here. I have 100 multiplying 10% minus. That's equal to 100 minus 10%. That's how we write in our calculator here. This is equal to 90. Great, because that's obvious. If we have 100 minus 10% of 100, what is 10% of 100? 10. That's equal to 9. Great, but let's multiply 100 per 0.9, just as we have seen here. That's equal to the same number. So, concluding this idea, if we have a decrease of 10%, we have 0.9 of the number. Of 20%, 0.8. Of 100%, 0. Great, guys, so let's move on. Now let's talk about simple interest. Well, what means an interest? This might have happened to you. You're going to the bank with some relative, and when someone loans money, the bank charges a rate, an annual rate, for the number of money you are taking. And when you're going to pay, you're going to pay probably more than you took. And this difference between what you borrowed from the bank and what you're paying is called interest. It's basically the amount that the bank is going to earn giving you this loan, right? So we have a formula here to make it easier. Our final interest is going to be equal to our initial principal balance. That's it, the initial price that we invest, for example, multiply it by an annual interest rate, for example, 5% in a year, 10% in a year, and multiplying by the time in years. Take care. If you have, for example, 6 months, time is not equal to 6. Time is equal to 0.5, because that's half of a year. So our final amount is going to be our interest plus our initial principal balance. What is our final amount? It will be the amount that we would pay for the bank. For example, let's say that I borrow $500 from the bank. However, the bank offers me an annual interest rate of, let's call it 5%. And now I want to have this money I want to develop this money from 5 years from now. Time equals to 5 years. How much will the bank earn in this operation. So the interest, that is the margin, the difference between what I'm going to pay and what I have borrowed, is gonna be equal to the initial balance, $500, multiplying my annual interest rate. Remember, 5%. I'm not going to write 5 here. I'm going to write 5 divided by 100. That is the definition of 5% we have just seen. Multiplying t, that is the time in years. How many years it will take for me to develop the money for the bank? 5 here. So the interest the bank is going to earn with this operation will be, cutting zeros, this is equal to $125. Great, that's the interest. But now, how much will I develop to the bank? Let's call it the final amount. The final amount will be the interest, that is $125, what the bank earned, and the initial principal balance, that is what I borrowed. Okay, $500, giving me a total amount that I will have to pay for the bank of $625. This is basically what simple interest is. You have a constant annual rate above the same price. For example, this rate of 5% is always above $500. But notice something. This is simple interest. So if we have $500, in the next year, we're gonna have plus 5% of this $500. This is equal to 525. Okay? But seeing that this is simple interest, in the next year, we're gonna have plus 500, not above this new value. It's always on the initial value. We have plus 5% of 500. This is going to give us 550. If we had plus 5% of this new value, we would have compound interest. And this is what we are going to talk about in the next paper. Great, guys. So finally, let's talk a little bit about compound interest. In the last example, I spoke you about a loan in a bank. All right? So I showed you this situation. I have $500, and in the next month, I'm gonna have an interest of 5% above this 500. Do you agree with that? And in the next month, next year, 5% above these 500. And there you go. But when it comes to compound interest, things get a little bit harder. Now I'm gonna loan an amount of $500. The rate is still the same, 5%. The time is still the same, 5 years. But these 5% will not be constantly applied to 500 anymore. Now it will be applied to each different value every year. Let's give you this example. I have $500. In the next year, I'm gonna have an increase in the amount I will have to pay in 5%. of these $500, resulting in $525. In the next year, sorry, I'm gonna have an increase of 5%, but not above these 500 anymore. Instead, above this new value of 525. This is going to give me an X value. And in the next year, plus 5% of X. And this is why compound interest is more complicated, because it's not a constant where you will be applying your rate. Now you will apply your rate above the last value at the end of each year, all right? However, we have a formula as well to make things easier. A, we're gonna call final amount. P, the initial principal balance, just as in the simple interest. So this would be really difficult for me to calculate because it's not as simple as the first one. Compound interest, it's way harder for me to do in my hand. But if we use the formula, it's super easy. Let's see the final amount that I will have to pay for this loan with this rate after this period of time. This is gonna call A equals to, what is my initial principal balance? I took a loan of $500, multiplying 1 plus, sorry guys, this is R, the rate, 1 plus my rate, 0.05, that this is equal to 5%, raised to 5, this is equal to this, which gives us approximately $638. So you can see that this is way different from the simple interest. In the last example, I had $625, but now I have $628. Why I have this difference? Because in the last example, as I told you, my rate was always above this fixed value. In compound interest, this rate is always above the new value. I have 5% of the initial value, and after 5% of the new value, that is the initial value plus the first interest, and so on. A final example to clarify you. I put $1,000 in the bank, in my bank account, and there is a rate of investment that is 10% per year. Each year, my bank account will generate me 10% from the value I currently have. And I want to take this money after 10 years. Okay? Well, let's use the same formula. How much will I get after these 10 years? If my bank account generates a 10% increase in my current amount of money, well, the final amount will be my initial balance multiplying 1 plus the rate, that is 10%, or 0.1, raised to t, that is 10 years. This is equal to 1000 multiplying 1.1 raised to 10, and this is gonna give me approximately a final amount of $2,594. So that's the answer. After 10 years, in a rate of 10% per year, in my current amount of money, I'm gonna have $2,000 and 594. So this is basically what compound interest is. It's a little bit harder than simple, but you can rock it if you do the practice tests in Khan Academy or College Panda. So get motivated, because math is super cool when you understand it. So this was today's class, guys. See you next week.